everyone, I am Rovic Venturado of ECE38. Today I am going to present the last performance task, which is the architecture and microarchitecture. First topic is the architecture. The subtopics are the CPU or the central processing unit. This is referred to as the brain of the computer. The concept is the same as the Moore's law. This is the center of a device that receives all instructions in simple words. CPU rely on instructions in a program given to it. Next subtopic is the digital computers. So this is the history of the computers. 1940s, these are big, slow, and fragile computers. 1943, the first computer, the ENIAC, was created. But these computers are unreliable and error-prone because it was built with vacuum tube technology. In late 1940s, John von Neumann developed a computer architecture which has separate functions, that is to process, storing, and decoding. In the 1950s, a grand semiconductor-based transistor are developed. Next is the integrated circuit. Robert Noyce invented the first monolithic integrated circuit in 1959. In 1968, Integrated Electronics, or the Intel for short, was founded by Noyce and Moore. In 1971, Intel 4004, a single chip computer or IC, was developed, followed by the 8-bit microprocessor in 1972, which was the Intel 8008, and followed by the Intel 8086 as its successor. In 1978, the 16-bit 16-bit 8086 microprocessor. Next is the computing abstraction layers. Concept to understand the computer architecture. The notion and the use of binary system 1 and 0 and computing abstraction layers. So instruction set architecture, or ISA. ISA defines how the CPU is controlled by software. The ISA acts as an interface between the hardware and the software, specifying both what the processor is capable of doing as well as how it gets done. It is referred as the memory model, supported data types, registers, and behaviors of a machine code. Example of this is the x86, 68K, MIPS, ARM, and etc. A compiler in the software side uses ISA to transform code written in high-level languages, while the hardware side, the CPU architecture is being designed. Division of layers made ISA implementation independent. Though ISA is considered as a dictionary, other companies can develop microarchitecture based on a single ISA, and the added instructions are stored in that dictionary. Next topic is the key building blocks in CPU. First is the microarchitecture. The specific design of an ISA. This is the steps or stages. First is the fetch stage and the code stage. These two are the front end, and the execution and write back stage are the back end. The pipeline depth. The more stages is added, the less work of an individual stages. So Henry Ford built an assembly line with many stages in attempt to drive down the cost of Model T. The more pipeline stages, the faster it runs. Front end. This pipeline depth is synchronous, which is controlled by a clock. The speculations. So the branches or instructions, this is the decision point. As pipeline go further, the lesser its accuracy. Next is the branch prediction, wherein the decisions are accurate. And the last is the speculative executions, where work is done before it is known whether it's actually needed. So next is the predict and fetch. Learning from past behavior to know how future will behave. It takes longer to fetch data from memory than CPU. The cache is the temporary stage storage that can read memory in 1 to 2 stages or cycles. Next stage is the decode. Micro-operations is the instructions program are decoded. The additional 8-bit instructions helps decoding. Complex instructions have more or need more micro-operations. This can fuse multiple adjacent instructions for efficiency, as can be broken down to multiple uops combined or just in a single uops. Next stage is the execution stage, where the scalar execution or the simplest execution where only one instruction at a time. The superscalar execution is where the multiple ALUs are operated in parallel. So the in order execution, micro operations are operated in program ordered, while the out of order is the otherwise. CPU and CPU backend, the ROB or the reorder buffer to instructions or to put instructions back in order. The allocation, the ROB or the reorder buffer, gives us ability to understand the original order of the program. The vectors is where the multiple elements that ALU operates. Microops should be assigned to a particular ALU to execute respective operations. And the last is the retirement. The reorder buffer write backs the oldest